Alright, I forgot to do the actual, probably somewhat, somewhat useful, more useful than me stumbling through this for hours, but somewhat useful summary. Um, so the summary for this algorithm, my concoction of a solution, is so this is using the hint, can determine, can first find the number of ways to get increasing array, so like increasing array of size n less than or equal to n. So for example, if your n is 3 and your max is 5, then find ways to get size 1, 2, or 3 values in the range from 1 to 5 to get increasing array of size with values 1 through 5. And then from there, so technically that'd be size 1 would be just 1, 2, 1, 2, 3, 4, 5, and size 2 would be 1, 2, 1, 3, 1, 4, 1, 5, 2, 4, and size 3 would be 1, 2, 4. So for each secondly, use combinatorics to get number of non-decreasing arrays. So this is using the formula. So insight here is going to be if array has n numbers where there is k unique increasing values, there will be n minus 1 gaps where k minus 1 gaps have increasing differences. And if it's not increasing differences, then it's the repeating value. So for instance, let's say you're dealing with, so for example, n is 3, max is 5. If you have the size 2, right, size 2, this means you have 3 numbers where 2 of those numbers are increasing. So it could be the first 2 numbers, the second 2 numbers, the first and last number, they're increasing. But you note that the gaps between them, there's 2 gaps. And one of those gaps has to be increasing. So one of the 2 gaps between those 3 numbers are increasing. Right. And then you can just use the formula would be number of ways where k elements of n-sized array is increasing. This equals the number of ways to form k increasing values times the number of ways you can kind of wrap it around with repeating values or non-increasing values. Times basically n minus 1 choose k minus 1. Basically of the gaps, choose some number to have increasing deltas. Alright, and then basically it's going to be like, I don't even want to try to go through the logic again, but go create some way of determining what divisors there are of each number. So for instance, I made a graph. So for example, graph where nodes are values and connected to divisor nodes. So like 6 goes to 1, 6 goes to 1, 2, 5 goes to 1, 4 goes to 1, 2, 3 goes to 1, 2 goes to 1, 1 goes to nothing. And determine how many paths are of length, let's say m, where m is less than or equal to n. That will be equal to the number of ways to form unique arrays of that size, m, to be used in the above calculation. You do need to keep track of of the frequencies involved in getting to each number. So originally your frequencies are all 1, your values are 1 through max value, and then as you go through each value and you go through all the divisors of that value, you keep track of what the next n values might be. You say the frequency of that n value is going to be based on the frequency of the current value, and you keep track of how many there are, how many total ways of doing that there are. So the total, this is the combinatorics calculation right there. And yeah, all right. Time complexity, too long. This is O of n times O of the divisors of n, or the average number of divisors of n. The outer loop here is going through all the n values, which is originally is n. Or actually, sorry, this is O of max values. N is actually the size of thing. O of max values and times O of n because you are doing it for every. This is kind of funky. O of max values times O of the longest divisor streak, or divisor chain of n that is less than or equal to n. So you're never actually going to go longer than the longest chain. Yeah. And then space complexity, I just use a map. So those are all just going to be open for the frequency and counting race. All right.